Okay, once again, welcome all to this fifth webinar of DaCapo training and webinar series. So a little bit about DaCapo stands for Digital Assets and Tool for Circular Value Chains and Manufacturing Products. We are focusing on key areas such as introduction to new digital assets, AI-based systems, and process and products for digital twins. A bit about that we are 15 partners from 10 European countries. You can see it from the map. In this webinar series, which is hosted by AIMEN Manufacturing Group, which is the consortium partner of the DaCapo Group, myself, Ashwini Kumar, and with Professor Pinjone Martha from Manufacturing Group, I welcome you warmly all to this series, which aim to empower professionals for twin transitions by providing a valuable knowledge and tools to advance circular and sustainable products and business models. In this webinar series, you will gain insights from industry and academic leaders, engage with peers and share ideas during the webinar, and also take some actionable strategies for the real world impact. In today's webinar, which is on digital twins for circular manufacturing processes, we have three prominent scholars, Vicky from LMS, Alexander and Jorge from AIMEN Technology Centre, which is based in Spain. Before we proceed into details, there are some housekeeping rules. Please keep your microphone on mute. Use a chat box for comments and any kind of questions, and raise your hands during the webinar for any kind of interventions. So now I delete over it to you, to Vicky.
Thank you. I'll just share my screen. Hopefully it should be the right one. And yeah, so you should be able to see the slides. So welcome all from my side as well. My name is Vicky Panagiotopoulou, and I'm from the Laboratory for Manufacturing Systems and Automation. We are based at the University of Patras in Greece. And today we will talk about the digital twins that we have been developing in DaCapo, and more specifically in one of the use cases. But let me start a bit with an outline and introduction. Ashwini already mentioned about DaCapo, so just briefly the main information about it is a Horizon Europe project. It started in January 23. The aim was to develop human-centric digital tools and services in order to improve the adoption of circular economy in different manufacturing value chains. So this is our main work, to develop the digital assets and also to apply process and product digital twins, which is one of the things we're gonna discuss today, but also to improve the adoption of the circular economy. And we have three critical value chains in the project, which is the aeronautics, the consumer electronics, and warehouse and logistics. Maybe a few things why digital tools can support circularity. There are different ways so far to improve sustainability and circularity, and digital tools offer us the possibility to monitor and optimize energy consumption in order to increase the energy efficiency. It also provides us with tools to track the materials and the products throughout the value chains and also improve the supply chain transparency. Also supports the circular business models, but also builds circular economy ecosystems. A few things about the specific use case that we will describe today, which is our main focus, was the repair of a fan blade using machining and additive manufacturing process. So once you have a fan blade that needs to be repaired, first you need to remove part of the damaged part using machining processes. Then you add extra material with the additive manufacturing process in order to go to the original shape. And sometimes you might even have to remove some of the added material to ensure that you have the same dimensions as you had before. So in this use case, we developed digital twins to simulate and predict both energy and material consumption. And we did that in two different manufacturing levels. One was the process level to see how we can optimize the energy and the material deposition. and the other one was the machine level to account for any energy losses or even when extra energy consumption that might not be present in the process level. So digital twins, just overall definition to make sure that we're all on the same page, are the cyber representation systems of physical systems. This is why we have three main components: the physical system, the digital part, and also the information interaction between the two parts. Digital twins have been used in manufacturing for quite some time now. And what we did in this project, we follow the ISO 23247. This is why we have 4 different parts: the physical world, which we were trying to represent, the digital part, the interactions with the users, but also the interaction between the physical part and the digital part, which here it's depicted by the DaCapo platform. How we ended up developing the digital twins. First, we defined the design requirements. This was done with the support of the different use cases on what we want to predict and simulate. Then in phase 2, we represented the digital twins. And then we developed the digital twin approach and evaluate them either on, let's say, pilot case or in the end user premises. And that's for the project overall. For this specific tool, for these specific tools, we also develop an orchestrator. And just a definition about the orchestrator, it's a software that's designed as a real-time engine in order to provide dynamic control strategies and dynamic environments. And this is the one that helps the implementation of the digital twins. Some key features to have in mind is that the orchestrator defines the assets as the digital representation of the environment, includes both physical and digital assets. And by asset, we mean different resources, machines, services, and other IoT agents. It also defines the usage plan, so it gives priority to some machines or assets in regards to others, and also coordinates the interaction, the execution, and the signaling between the different assets. And last but not least, it monitors also the performance between the different features. So how did we develop this orchestrator? It was developed on Java programming language with Spring Framework and custom components. This is for the core orchestrator execution and for the scheduling engine. And it was done in a 3-layer architecture, as you can see here, with different layers and different technologies. Also, there were some digital twin files implemented to the orchestrator in order to contain all the information that was needed from the different digital twins, not just from this use case, but from other use cases as well. And it also enables the deployment of the digital twin in the orchestrator by creating a dedicated workspace or folder, a zip folder. There was also this execution engine where the asset definition was implemented, installed, and it's available at all times. And also we had some IoT sensors representing some relevant values and machine controllers in order to have the data necessary for the implementation of the digital twins. And last but not least, there was a development of a user interface to make sure that this is user-friendly as well. And moving on to the digital twin, before a few words, LMS was in charge of developing the digital twin for the machining part, and AIMEN was in charge of developing the digital twin for the additive manufacturing part. So starting from the machining, this was a data-driven digital twin focusing on the machining process. The aim here was to predict the machining result, but also to estimate the energy consumption. We collected some data from sensors, and these were mainly temperature, spindle speed, and the coolant fluid consumption, which help us to develop the digital twin. And we also consider some alternative scenarios, and we will evaluate them in the process in order to further optimize the energy consumption during repair. So how this is done? This is done in two phases. In phase one, the user logs into the DaCapo software, and then the DaCapo Twin API is popping. And then we need to consider which of the data will be implemented into the digital twin. Here you can see the outcome of this work. We have configured 3 different virtual sensors for this scenario. The one was the temperature, the spindle speed, and the coolant fluid. These virtual sensors will be later replaced by real-time sensors when we implement that in the industrial partner. So the orchestrator receives this data and also instructs the digital twin to do the prediction. This is also done via the via the middleware that we have in the DaCapo. And here you can see the different energy consumptions. You can see in the top left the individual points, but also some normalization that had to be done. And also, if we consider that multiple machines were also used, we can also add that up to the digital twin, so you can see the total energy consumption from the different digital tools. This was like a very generic description of the LMS digital twin on orchestrator, just to see what the features of it. And then I will pass on the floor to my AIMEN colleagues if they want to share the screen as well for the digital twin software from AIMEN side.
Okay. Can you see the screen? Yes? Okay. This is Alessandro from AIMEN. I'm here with Jorge, and I will show to you the software that we developed to do a digital twin focus on additive manufacturing. Okay. This is a software called Smart Hub. It's a standard software at the facilities at AIMEN. And we developed some plugins to this software to capture in real time all the information for the process that we need. For example, in this project, we capture the position of the robot, the information of a thermal camera, the consumption of the robot, of the laser, and so on. And we save it in a coordinated way in a format that it can explode by the ParaView software, a BTP format, and we can share it in real time through a OPC way server if some partner want to see it in real time, or if you need to see it in offline way, you can see it like through the ParaView software. In concrete, in DaCapo project, we use information from 4 sources. One source is the robot, the BB robot that we have in the cell, a NIT camera, the NIT camera, that is a thermal camera, okay? A webcam to show the process or to record the process, and a backup PLC that is connected to a several hardware to can save the consumption of all the hardware that are involved in the process. About the OPC-Y server that I talked before, you have the information ordered in 4 ways that you have the robot, the camera, the webcam, and the consumptions. And if you are in other part of the world, you can see it directly if AIMEN give access to you. About the hardware in the installation and talking about the consumption, you have the Smart Hub that have all the data in real time, have a plugin to connect to the backup system. I have the backup system that you see in this slide. You have a PLC, a switch, and a several decentralized system that have several rings connected to all the systems that are involved in the process. These city rings can save the amperes and the voltage and the watts and the energy of all the process. We have a main PLC and a decentralized rings and system connect all the facilities that are involved in the process that the manufacturing of AIMEN. And with the other system, we can capture and merge all the information in a same format and with the same timeline. This is an example of all the variables that you have mapping from consumption way. For example, the active power of the robot, the active energy of the robot, the power factor of the robot, the same for the laser, the same for the cooling system, the same for the VLC system, that is the same for the air pump system, all the systems that the people in the process. And you have another information for the process. For example, you have for the robot the X, Y, Z position, the speed, the power of the laser, the gas of the VLC, and so on. And you have the webcams of the video, the video of the process, and the thermal information of the process, of the infrared image of the process. Okay, you can see now in the screen a video of the software when the process is doing. This is the robot moving. You can see the IR image and the consumptions, the velocity of the robot, and so on in real time. After it, when you finish the process, you can save it in a file that is compatible with ParaView or other software, and you can see all the information together. In the next slide, if it's changed, okay, sorry. You can see all the information. This is an offline way, okay? And you can see all the information together. For example, in the middle of the image, you can see the energy that the process needs to do, and you can see the colors depending on the energy in the part of the welding. This is the digital twin, the offline digital twin with all the information. You can see the active power, the active energy, and you can graph it in a synchronous way. We are selecting all the information that what we need to see. And on the right corner, you can see the infrared image with the extrapolated data with the melt pool area and so on. And we can graph it and show it in different colors to have information about the process. For example, you are seeing the melt pool area, the melt pool width, the gray value of the welding, and with this you can see if the process is good, is not, if you have some error. You have all the information in the same timeline together.
Yeah, yes, one moment. Just to clarify, what you are seeing on the left hand is the representation, in this case, of the melt pool area in each robot position. So now, in this case, we are building four walls, four parallel walls with, I think there is 1, 2, 3, 4 layers each wall. So you can see 4 tracks for each wall, and you can see in this case how the melt pool is varying from one to the other. Probably in this case, on the right, we have less melt pool dimensions than on the left wall, because the heat is accumulating and the melt pool is increasing during the process. Okay.
Okay, I think that is all for us. Yes.
Okay, thank you. So I'll just do the wrap up. Just give me a second, please. So today in this webinar, we presented the digital twins for simulating the repair of a fan blade for both machining and additive manufacturing processes. And we focus on predicting and simulating the energy and the material consumption. These digital twins are part of the DaCapo platform, so they're exchanging data with other digital tools in order to increase circularity, but also to improve sustainability. Such tools are a life cycle assessment tool or the digital product passport. And for future work, I would like to demonstrate the applicability of the digital twins in the industrial facilities, and also to check their operability with real-time data, but also to include other processes, but also to address other additional industrial sectors. And with that note, I would like to thank my colleagues from AIMEN, Alexandra and Jorge, and we are open for any questions from the audience. So thank you everyone for your attention.
Thank you all for the great presentations. And before we get into Q&A, just the last couple of information I would like to share with our participants. Hi everyone, your feedback is very valuable to us, so please take 5 minutes to leave your feedback by scanning the code, or you can find this link in the chat box. Also, we would like to take the opportunity to update you about upcoming webinars in the month of May, June and September. Here is the information. Also, you will find the link for our Eventbrite page where you can access all of these webinars and register for yourself for future participations. Once again, thank you and see you on May 30th. Now the floor is open for any kind of Q&A. We really encourage great participation. Please feel free, any kind of question. You can paste in the chat or turn on your mic and directly interact with our presenters. Hi Vicky, we got some more time in case if you would like to inform more about which were not in the slides, or so we have a great deal of time to inform better and like further on this.
Okay, or we can redo the whole presentation. Yeah, I'm not sure if everything was so clear that there was no question, or everything was so unclear that people are. But I think we have a question.
Yes, we have.
So if I read the question, maybe how do you think economies can finance digital twin infrastructures in cities? So maybe Marvin, do you want to explain a bit more about it? Are you talking about digital twins for cities, or maybe I'm not getting the question? So right, because we're talking about manufacturing processes so far. So okay. Yes, that's a kind of difficult question to ask, or at least from my side, because our background is mostly on the manufacturing sector. And then we know that there is a great interest from companies themselves as they see the benefit of having the digital twins in order, especially for optimizing energy consumption and material consumption, because that saves them a lot of money. But I guess on a larger extent, the economy should also support this part as well, especially if they see successful examples from other sectors. But how and why? And it seems a bit politically, borderline politically, this question. So, but I hope I've answered it as best as I could. I don't know the colleagues from AIMEN if they want to add anything on that, from their experience.
Yes, I think that it's possible to sensorize a city because you can the consumption of the city and merge it with the position of the consumption, and for example for the pollution or I think that can be used in some ways. Right now there are a kind of digital twin because you have the traffic in real time and something like that. It's similar, that you can merge all the information in one big digital twin of the city. Of course, I think that in the future it will be necessary, and I think that Google is doing it right now with some things. But I think that in the future Europe must be do it, in my opinion.
We are still open for many questions. Please feel free to be actively participate.
Hello, Marco Cinelli from Leiden University. Thank you very much for the presentation. My question is on what the foreseen use of this digital twin. Well, I mean, what type of information can it provide in addition to the energy consumption as well as the modeling of the laser? And what type of decisions can it help make? Sorry, I'm on an airplane, so that's why it's a bit noisy. I'll turn off my.
Sorry, was that a question from me or for the AIMEN team? Sorry, I heard at some point laser, and I thought it was like AIMEN.
I guess you can decide. The point is what type of decision support capabilities does this platform have? Meaning what can you see in real time and what type of decisions can be taken based on what your tool does.
Yes, as Alessandra mentioned during the presentation, we are mainly focused on measuring the energy consumption of the different equipment of the laser cell, not only the laser, but the robot, the powder feeder, and also the airport system, and so on. And also the material consumption, because, for example, we are using some sensors to measure the powder flow of the material that we are using as a feedstock to add material during the additive manufacturing process. So we are collecting all this data, and also the data of the road position, orientation of the axis of the robot, and also of the external axis that we are using to manufacture to carry out the additive manufacturing process. And we are using it to model the energy consumption of all the laser cell, not focus mainly on the laser, but in all the elements of the laser cell. And also, now we are with the aid of the infrared camera, we are implementing a process control regarding the melt, just looking at the melt pool and looking at the powder feeding. So we are trying to keep constant or adapt the powder feeding and adapt the laser power to keep the process as constant and as smooth as possible. That's the main features that we intend with implementation of this digital twin.
Oh, really cool. Thank you very much.
Vicky, we have 3 more questions. We can take one by one. Today, we have someone like from economics background, I think, so asking on economics and innovation around. So first question is, how can you think this will help startups? And feel free to answer, like anyone from the AIMEN side or Vicky yourself.
I guess we're still on the topic of developing digital twins, or we are on the digital twins for cities. I'm kind of confused right now. I'm not sure if it's a continuation from previous question, but I think in general, startups are quite active in this digital twin development. Hi,
Marvin, can you explain all 3 questions? Are they
It's a continuation.
Okay, great.
Yeah. So I guess we will need the support. I mean, it's already been mentioned that we will need different sensors or things that are already been done. So I guess startups could actually play a role here. So to increase also the number of startups. But as for the rest of the questions, as Srini mentioned, they're very on the finances side of things, so especially the one on the consumerism. So I don't know, Srini, if your expertise also can help us understand the question.
Let's say I can help to answer the second one about consumerism, because I can, in my latest last 2-3 experience, there is a huge inclination toward the smart homes. using
Okay.
digital technologies and AI. So definitely when it comes to these tools and the developed technology and sensor will be integrated in our daily life, which is like this market is constantly growing, especially in Europe. So yes, this will induce and propel the consumerism further.
Okay. That was a good one. Thank you. And maybe the last one, that there is a monitoring and evaluating tool on the use of digital twins in manufacturing technologies. I would say that in our case, partially this is done by the orchestrator because it can monitor the performance of the different tools that are associated with that and the different assets. But in general, I think through the different tools, because I mean, digital twins are normally not standalone tools. There is some kind of performance and monitoring. And I think there is a new question, how do we deal with the disposal of e-waste? But that sounds a bit philosophical to me at this point. I mean, we are all concerned about also the carbon emissions or carbon footprint related to the digital part of our activities as well. It's something that we have not considered in this project, or at least for the development of the digital twins for the machining part, but we can take it into consideration.
We have one more questions regarding the overall, let's say, circularity assessment through our project, which is mainly all about circularity, like different R cycles and all that. So Vidya has posted a big questions. So let me reiterate it for you. Yeah, I'm Vidya.
Thank you.
I am using asset administration shell to create a digital twin for building digital product passport of assets. I am looking to use the static and real-time data of the assets from sensors for building predictive maintenance of the assets. Could you please explain a bit more on the circularity aspect of the project shared by you?
Okay. It's first of all, thank you for your question. I understand that our projects or the work we're doing are quite similar, or at least they're on the, let's say, the same direction using similar tools. Unfortunately, I'm not the one that was so involved in this technical part. I know that in our project, there is this asset administration cell modeling as well that we take into account. But there are other partners that are more involved in this part, the AES and the DPP as well. I mean, you can always visit the website of DaCapo to learn a few things more, or if you want, we can provide you the some contact with the partners that are involved that can bring that can reply to you in details, because I think this is a technical question. I don't know, Ashwini, do you want to add anything more on that?
Yeah, yes, that's what I was thinking. Thanks for speaking my mind. That Vidya, we can come back to you via email in detailed answer and very like accurate. So instead of little bit misinforming you, we will reach out to our related consortium partner who are involved in this administration cell and we will answer you in detail for sure, like maybe by end of the day or tomorrow.
Thank you so much for answering my question. So, I mean, I just give a context of what I was working on, and then so the digital product passport circularity aspect of that is quite understood by me. But when I saw your project, I was trying to understand what's the circularity part. That's why I just asked that question. But yeah, I'll look forward for your links and I'll follow up there. Thank you.
Thank you.
We have a couple of minutes more, so always welcoming question. Hi Marvin, before I request Vicky to answer your question, I also can briefly inform you on this. Whole circularity as a concept is about reducing the consumptions, and before we produce or design and extract a raw material for the new product is all about rethinking, repurposing, which we known as R cycles. There are total, as if I'm thinking out loud, there are R9, which is called 9 cycle of circularity. One of the initial ones are like repurposing and redesigning or refurbishing. These cycles help us to reduce the let's say virgin materials for any new product. I hope I answered you well, and maybe Vicky can add on this a bit more.
Yeah, for sure. I mean, recycling or use, let's say, materials that have already been processed instead of raw materials. It's something that can be done in general. Is not the focus of the DaCapo project itself, because we are focusing on, let's say, higher R cycles, on repairing, remanufacturing. So things are, for products that are already available there, we just want to expand their lifetime. But I think, Ashwini, you're pretty right on that one. And Marvin as well points out very well that also the consumer part is very important on that. Just trying to be a bit more focusing, let's say, on circular products or materials that have been used in the past. It's something that we can, as consumers, support this transition to circularity.
Yes, Marvin, also to add on in the same continuation, let's say the overall agenda of sustainability is around that we are the stewards of our planet Earth, not the owner. So definitely the whole, let's say one of the element that I think out loud is about sustainability and circularity is to be more aware consumer from our side. And to be more aware consumer, yes, as you pointed out rightly, that instead of buying a new products, we are also one of the key, let's say, KPI or element in circularity is to extend the life cycle of a product, which can done through the, as Vicky just mentioned, through recycling, refurbishing, and earlier recycles like repurposing, all about this. So all our cycle is to extend the life cycle of a product. If there are no more questions, maybe we can take a leave from here. What do you suggest, Vicky? Still?
No, I think I agree. It looks like most questions were answered.
Thank you. Thank you, everyone. Please visit our website and register for the upcoming webinars. Also, a request to share your valuable feedback with us through these forms, because it will help us to improve our future deliverables. And thanks once again for the kind participation and active participation through your Q&A. See you in 1 week almost, on 30th of May, with our next webinar in this series. Thank you again.
Thank you, Ashwini, for your coordination.
Have a good day.
Thank you very much. Thank you.
Bye. See you, Ashwini.